Welcome back to online class. Today we are going to discuss third unit fluids. Learning objectives. After completing this lesson, you will be able to define pressure in terms of weight, explain the variation of pressure with respect to depth in a fluid, density of a liquid, relative density of an object, behavior of floating bodies. What are fluids? All the flowing substances, both liquids and gases, are called fluids. So, liquids and gases share some common characteristics. They have many distinctive characteristics on their own. It is easy to compress a gas, whereas liquids are incompressible. Learning of all these facts helps us to understand pressure better. In this lesson, we will study about pressure in fluids, density of fluids and their application in practical life. Now let us see thrust. What is thrust? The force acting perpendicular to the surface. The force acting perpendicular to the surface. This is called as which one? Thrust. It's nothing but force, isn't it? So, the SI unit of thrust is Newton. What is thrust? Force acting perpendicular to the surface. So, let us consider this is a surface. Here the force is applied. So, the force is applied or acting perpendicular to the surface. This is called as what? Thrust. What is the SI unit of thrust? It's Newton. Okay. Now let us see one small activity. Stand on loose sand. You know what is sand, isn't it? Your feet go deep into the sand. Now lie down on the sand. What happens? You will find that your body will not go that deep into the sand. Why? You will find that your body will not go that deep into the sand. Why? When you stand on loose sand, the force is acting on a area equal to area of your feet. So, the force is acting on an area. So, which is equal to what? The area of your feet. Okay. Now, when you lie down, the same force acts on an area of our whole body which is larger than the area of your feet. Okay. So, which one is larger? The same force acts on the area of a whole body which is larger than the area of your feet. Okay. Therefore, the effect of thrust depends on the area on which it acts. It's depending upon the area only. The effect of thrust on sand is larger while standing than while lying. This is the reason. Okay. So, the force per unit area acting on an object is called pressure. So, what is pressure? The force acting or the force per unit area acting on an object is concerned is called pressure. So, what is the pressure formula? Pressure is equal to thrust by area of contact. What is the pressure formula? Thrust by area of contact. What is the unit of pressure? That is Newton per square meter. Newton per square meter. This is the unit. Okay. So, in SI units, we can write the unit of thrust and pressure. In SI units, the unit of thrust is Newton. It is denoted by the symbol is capital N. Already we know that is needed. The unit of pressure is Newton per square meter, or we can using which one? Newton meter power minus 2. Both are same. Newton meter power minus 2. In the honor of the great scientist Blaise Pascal, there is 1 Newton per square meter is called as 1 Pascal. So we can write 1 Newton meter power minus 2 is equal to 1 Pascal. It is denoted by the symbol is PA. I hope you understand. So we have discussed what is thrust and what is pressure. Okay. So see the formula. Already we know that. What is the pressure formula? Pressure P is equal to thrust. What is thrust? It's nothing but force. Isn't it? That is force by unit area. This is called as what? Pressure. See the figure. For the same given force, if the area is larger, see here, this is the area, okay? So the A is larger here. What about the pressure? The pressure and area both are inversely proportional to each other. So here the area is increases. What about the pressure? The pressure is decreases. Both are inversely proportional to each other. Suppose area decreases. So what about the pressure? The pressure increases. See the diagram also. Okay, see the figure. For this same given force, if the area is large, the pressure is low because both are inversely proportional to each other. It's given as low pressure. And see the second figure, this the area is small, isn't it? So the area is decreases. What about the pressure? The pressure is high pressure. So the pressure is depends on the area of application. I hope you understand. Okay. Now let us move on to a pressure in fluids. All the flowing substances, already we have discussed, both liquids and gases are called which one? Fluids, isn't it? Like solids, fluids also have weight and therefore exert pressure. When filled in a container, the pressure of the fluid is exerted in all directions. So the pressure is exerted in all the directions and at all points of the fluid. Since the molecules of a fluid are in constant, rapid motion, the particles are likely to move equally in any directions. So see here, this is the gas molecules. The gas molecules are move equally in all the directions. So the one direction, this is another direction. It's not in the regular manner, it's a random manner. This is only is given as rapid motion. Therefore, the pressure exerted by the fluid acts on an object from all directions. See the figure also. Here the pressure is exerted in all the directions. The first one is given as which one? The fluid. That's the pressure of the fluid is exerted in all the directions. It's given. This is one direction. So this is another directions like that. It's given. And second, we have to consider as the molecules of a fluid. Here also the particles are, the molecules are likely to move equally in all direction. This is a gas molecules and this arrow mark indicates which one? The gas pressure. Okay. So the pressure in fluids can be calculated. So we can using the formula fluid pressure. I am writing FP, that is fluid pressure is equal to the total force exerted by the fluid is nothing but force, isn't it? Force by area over which the force is exerted. In which area the force is exerted. So the ratio between the total force exerted by the fluid to the area over which the force is exerted. So what is the formula? Fluid pressure is equal to F by A. I hope you understand, ma. So what is the pressure formula? The fluid pressure, that is F by A. What is F? The total force exerted by the fluid. What is A? Area over which the force is exerted. So this is what? The pressure in fluids. I hope you understand what and all we have discussed in this video. Thank you, students.